Welcome to my YouTube channel, Techie San.
Concepts of memory hierarchy. Locality of reference. The first thing that we need to discuss is temporal locality. Recently accessed data is likely to be accessed again soon. This is why data stays in faster memory like cache for quicker access. Spatial locality. Data near recently accessed data is likely to be accessed next. Memory management takes data of this by preloading adjacent memory blocks into cache. Okay, so what the basic temporal locality is that whatever that is used recently, whatever the data that is recently used, that will be used again and again. Okay, so what I will just do is that instead of throwing the data into the memory, I will place the data in the cache memory for quicker access. If I place the data in the memory, it takes more clock cycle. But if I place the data in the cache memory, it takes less clock cycle. That is why the recently used data or accessed data that will be placed in the temporal locality. But once it is processed, it is immediately we know that the next adjacent to the accessed data, the next block will be the next access data. So what I will just do is that the I will preload the adjacent memory blocks also into cache memory. I will access the current access data and also I will throw adjacent memory blocks into the cache memory. Okay, that is why that I will call it as spatial locality. The next point is cache coherence. In systems with multiple processors or cores, cache coherence ensures that copies of data in different caches are kept consistent. Without cache coherence, processor might read stale or inconsistent data. Now, if I have only one processor, I don't have any problem in using cache. But imagine that if I have multiple cores for single application. In that case, there comes cache coherence. Okay. So without cache coherence, it cannot read stale or inconsistent data. The processor might stale or inconsistent data. That will happen without cache coherence. So cache coherence is important. When you consider multiple core, in that case, it is a must that you have to think about cache coherence also. If it is single processor, there is no necessity for it. Okay. And next thing is latency and throughput. Latency, the delay in accessing data from given memory level. For example, accessing data from registers is almost instantaneous, while accessing data from storage, secondary storage, can take significantly longer. That is, the delay in taking the data from registers is instantaneous. That is, immediately it can take the data from the registers. But in case if the data is stored in the secondary storage, that is hard disk, or secondary hard disk, in that case, it will take more clock cycle. That I will call it as latency. Throughput, the rate at which data can be transferred between memory and the CPU. Faster memory types provides higher throughputs. Okay. Now we will be connecting memory and the CPU. We should also calculate at what speed the data is transferred between memory and CPU. That we have to calculate. That is throughput. Memory access method, direct memory access. If peripheral want to transfer the data to memory, or memory wants to transfer the data to peripheral directly without involving CPU, the best thing is that we have to go for direct memory access in that case. So you can improve power consumption. You can offload your CPU. So you can put your CPU into sleep mode. So power consumption will be less and performance will be improved because at higher rate, data will be transferred from peripheral to memory or memory to peripheral.
Thank you, friends.